The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at vmail@ybcc.edu and I will respond as soon as I can. All right, so today we're going to go on to section 10.4, part 1, which involves graphing second degree or quadratic equations. So let's get started here, and we're going to switch screens, hopefully successfully. We shall see what happens. Okay. All right, so here we have a basic second degree or quadratic function, f of x equals x squared, which could also be written y equals x squared. And what I want to do is I want to create a table of values that we can use to graph. So let's say that x is -3. Then f, let's see here. Is it already being uncooperative? Let's find out. Then f, here we go, of -3 would be -3 the quantity squared, which is 9. So -3, 9. If x is -2, f of -2 equals -2 the quantity squared, which is 4. So -2, 4. If x is -1, f of -1 equals -1 the quantity squared, which is 1. If x is 0, f of 0 equals 0 squared, which is 0. If x is 1, f of 1 equals 1 squared, which is 1. If x is 2, f of 2 equals 2 squared, which is 4. And if x is 3, f of 3 equals 3 squared, which is 9. Well, as you can see, unless I've messed up terribly, the graph is not going to produce a straight line. It's going to produce what is called a parabola. Okay, and let me see if I can draw a decent graph of the parabola. I'll tell you what, let's just go on to the next page and we can see, that's what it would look like. Okay, now I want to point out some characteristics of a parabola. This point right here is called the vertex. Okay, if a parabola opens upward, which is what we say this one does, the vertex is the lowest point on the graph. If a parabola opens downwards, which we'll be looking at eventually, then the high point is the vertex of the graph. Also, a vertical line running through the vertex is called the axis of symmetry. Axis of symmetry. In this case, the axis of symmetry would be x equals 0, or the y-axis. Okay, so the graph of f of x equals x squared is this parabola opening upward with a vertex at 0, 0, and an axis of symmetry, a vertical line going through the vertex, and the equation of that line is x equals 0. Well, now let's take a look at this red function, f of x equals x squared plus 3. And let's see what we get when we plot, or we finish this table and plot those points. All right, so oops, it's doing it again. Okay, all right, I tested this earlier and everything was going to be fine, so let's see what's happening. Let's go here, let's go back here, and let's see. I think things are working out. There we go. F of -3 equals -3 squared plus 3, which is 9 plus 3, which is 12. Okay. F of -2 is -2 squared plus 3, which is 4 plus 3, which is 7. F of -1 equals -1 squared plus 3, which is 1 plus 3, which is 4. Do you see what's happening? This part of this new equation is just like the old equation, but then we're adding 3. So these values, these y values, are 3 greater than these y values. So this is going to be what? 3, 4, 7, and 12. Okay? Now, I want to back up for a minute. I talked a little bit about the axis of symmetry, and what I neglected to do was to point out that when we look at f of x equals x squared, excuse me, we've got some repeated y values, which is why we've got this sort of reflection across the y-axis, okay? Same thing with this new graph. We've got some repeated values here, all right? But again, these y values are all 3 larger than in the previous graph. So what's the red graph going to look like? Just like the black graph, except everything's going to be moved up 3 units. So let's see here. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 2, 3, 1, 2, 3, 1, 2, 3. So our graph is going to look like, well, let's see here if I can get the picture. Trying to line it up. And then we've got this little bit here. Okay, so the red graph looks just like the black graph, except it's been moved up 3 units. So whereas in the original, let's see here, in the original black graph, the vertex is at 0, 0. Now in the red graph, where did my mouse go? Oh, here it is. Okay. Try to get it to go over here. In the new graph, it's at 0, 3, the vertex. Okay. The axis of symmetry is still the same. All that happened is the graph moved 3 units upward. Okay, now let's take a look at this graph. F of x equals x squared is already drawn. F of x equals x squared minus 4. So how are these values going to compare to those values? Well, the x squared would be the same, but once we find x squared, what are we going to do? We're going to subtract 4. So this value is going to be 9 minus 4, which is 5. This value is going to be 4 minus 4, which is 0. 1 minus 4 is -3. 0 minus 4 is -4. 1 minus 4 is -3, and then 0, and then 5. Okay? And if we graph those points, let's see, -3, 5, -2, 0, -1, -3, 0, -4, etc., etc. We get a graph. Hang on here. That looks like this. Okay, so same shape as the f of x equals x squared. So the red graph is the same shape as the black graph, but it's been moved down 4 units. Where's the vertex? It's 0, -4. Okay, axis of symmetry is the same as before. So if we have, let's go back here. We have this graph, f of x equals x squared. We get a parabola that opens upward that has a vertex at 0, 0. Then as we go on to this, it moves down 3, oh, excuse me, plus 3. I can't read that because it's covered up. Plus 3 moves it up 3 units. Minus 4 moves it down 4 units. So a constant term out at the end of the equation causes a vertical shift. A positive number moves up, a negative number moves down. All right, let's take a look at this situation. This is going to be a little more complicated. All right, now over here we have the black equation along with the black graph, f of x equals x squared. All right, but I want to graph f of x equals x minus 2 squared. Now the minus 2 is not outside the square, it's inside. But here's what I want to do. I want to think in terms of what do I need to do to my x values to get the same y values as before. Okay, if I put in these x values, I'm going to get something very different. Let's see. If x is -3, -3 minus 2 is -5 squared would, quantity squared would be 25. If x is -2, -2 minus 2 is -4. -4, the quantity squared is 16. If x is -1, -1 minus 3 is -3. -3, the quantity squared is 9. If x is 0, let's see, 0 minus 2 is -2. -2, the quantity squared is 4. I'm starting to get these values, but let's see. So -1 and 0 produce the 9 and the 4. But how does this number relate to this number? And how does this number relate to that number? Well, the red equation, f of x equals x minus 2 squared. We put an x value in. The next thing we do is subtract 2, and then we square the results. So if we want to get a 9, just like we got a 9 over here, well, if we put -3 in there and subtract 2, and we square it, we're not going to get 9. Since we're subtracting 2 here, if we add 2 to start with, so the original x value, -3, plus 2, -1, if we put -1 in there, subtract 2, we get -3, we square -3, we get 9. What I'm getting at is these values need to be 2 more than those values. So -3 plus 2 is -1. -2 plus 2 is 0. -1 minus 2 is, let's see, add 2. -1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. 3 plus 2 is 5. Let's think about this. -1 minus 2, -3, the quantity squared is 9. 0 minus 2, -2, the quantity squared is 4. 1 minus 2 is -1. -1, the quantity squared is 1. So again, what am I doing? My x values are 2 greater than they were before, but my y values are all the same. Let's see what happens here. -1, 9, 0, 4, 1, 1, 2, 0, 3, 1, 4, 4, 5, 9. Right. And if I graph that, okay. What does that graph look like? The same shape as the black graph, but it's moved to the right 2 units. The vertex is now at 2, 0. The axis of symmetry would be at x equals +2. Okay? So by going inside the square, we caused a horizontal shift. But notice, okay, let's go back here. When we went +3 outside, it moved us up 3. When we went -4 outside, it moved us down 4. So positive moved up, negative moved, down. But here, a -2 inside actually moved it in a positive x direction. So it was the inverse of what we would have expected. How about this one, a +4? Well, if that's true, then a +4 should move it 4 units in a negative direction. Let's see if that's correct. And if we move this over 4 units, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 4. Let's see. 1, 2, 3, 4, 5, 6, 7. -7. Well, if we take this and we subtract 4, we get that. If we take this and we subtract 4, we get that. If we take this and we subtract 4, we get that. This -4 is that. This -4 is -3. This -4 is -2. This -4 is -1. That describes it, doesn't it? So again, a +4 inside moved the graph to the left 4 units. So what's going on here? Well, let's see if I can, first of all, if I can get the graph, that would help. Just free-handed here. Now the vertex is at what? -4, 0. So let's go back again. Here. +3 outside moved it up 3 units. -4 outside moved it down 4 units. So what happened outside was obvious. Positive went up, negative went down. -2 inside went the inverse. It went 2 to the right. +4 inside went 4 to the left. Let's see what a negative does. Well, wouldn't this be the same as that? Because you'd put the number in. So f of -3 equals negative the quantity x squared, which is -9. So you do the square and then apply the negative sign. So these are all going to be switched. So where's that going to be? Well, we're going to have a picture of a graph, oops, pathetic picture at that, that opens downward, okay? So if there's a negative sign out in front, it switches the parabola opening downwards. What about this? Well, there's the x squared. So if I take f of -3, it's going to be 2 times -3 squared, which is 2 times 9, which is 18. So aren't I finding those values and then just doubling them? Yeah. So what's that graph going to look like? Well, let's see. -3, 18. I didn't give myself enough room on this graph, but -2, 8 would be right there. -1, 2, 0, 0, 1, 2, 2, 8. So by putting a 2 in front, it doubles the output values. It kind of stretches it vertically. What about a half? Well, now what are we going to do? We're going to square it, but then cut it in half. So this is going to be 9 halves, 4 halves, which is 2, 1 half, 0 halves, 1 half, 4 halves, which is 2, 9 halves. Okay. So -3, 4 1/2, -2, 2, -1 is a half, 0, 0, a half, 2, and there. So now our graph is going to open up wider, because for the same x, the y value is only half of what it was before. So this y value is only half of what it was before. This y value is only half of what it was before. All right, so let's see if we can kind of summarize all of this. If we've got something in the form y equals a times x minus h squared plus k, this is a formula, okay? If a is greater than 0, the parabola opens upward. If a is less than 0, the parabola opens downwards. The axis of symmetry is at x equals h, and the vertex is at h comma k. No, remember, what happened outside was what we would have expected. What happened inside was the inverse. So let's say I've got the following equation. Y equals x plus 2, the quantity squared, plus 3. All right. A, in this case, is the implied 1 that's out front, okay? So if a equals 1, that means it's going to open upwards. The axis of symmetry would be at x equals, it would be the inverse of what's inside. So x equals -2. When we're graphing freehand, we graph the axis of symmetry as a dotted vertical line. It's not part of the graph, but it helps us establish where the symmetry of the graph is. Also, it gives us the x value of the vertex. Okay. So let's see. We said the axis of symmetry. The vertex is at hk, which would be -2, 3. -2, 3. How do I know that? Because it's the inverse of what's inside and the obvious of what's outside. So -2, 3. Now, I've got a parabola that opens upwards, and the vertex is at -2, 3. What I'm going to do now is make a table, and I'm going to find 7 values, but I'm going to put the vertex in the middle of the table. And then I'm going to go to the left and to the right with integers. So this is -2, -3, -4, -5, -2, -1, 0, and 1. That will give me values close to the vertex, which will allow me to graph this thing. Okay, so now let me go back here, and I'm going to, let's see, let's rewrite this so it's more legible. X plus 2 squared plus 3. Okay. X plus 2 squared plus 3. All right, let's put in -5. So we get y equals -5 plus 2 squared plus 3, which is -3 squared plus 3, which is 9 plus 3, which is 12. Okay, so there's that. 12. -4. Y equals -4 plus 2 plus 3 squared, that is, which is -2 squared plus 3, which is 4 plus 3, which is 7. So -4 is at 7. Okay. -3. Y equals -3 plus 2, the quantity squared, plus 3, which is -1 squared plus 3, which is 1 plus 3, which is 4. -3, 4. And I'm also going to get these same values. I'm not going to take the time to calculate it right now, but we get this graph. The vertex is at -2, 3. The axis of symmetry is x equals -2. So again, finding the vertex, plugging that into the table, going to the left and the right with some integer values gives us a good shape, or a good shape to graph. All right, now what I want to do next is I want to go to WebAssign and show you in WebAssign how to graph this thing. Okay, graphing it freehand on graph paper, which is what we'd be doing if we were in a normal classroom, you would do it this way. You'd find the axis of symmetry and the vertex, and then plot, put that vertex in the center of your table, find some table values, graph it. Okay. In WebAssign, we do things a bit differently. Okay. All right, here. Okay. Let's see here. Let's do this. Okay. Give me just another minute. Oh, okay. So here it says, find the vertex and the axis of symmetry of the graph of the function. All right. So the vertex would be at hk. Keep in mind, x minus h, the quantity squared, plus k. So h is going to be 1, and k is going to be 8. So the vertex is at 1, 8. The axis of symmetry is at x equals h, x equals 1. Now, consistently, students get this wrong on their test. They don't write x equals for the axis of symmetry. It's the equation of a line. You can't just put 1 in there, okay? Let me show you what happens. We'll just put 1 in there. Oh, wait, let's see, a is what? 1, so it's going to open upward. So let's submit the answer and see what it says. It says that's wrong. We've got to put in x equals 1. Now let's see what it says. So the axis of symmetry is an equation. It's always x equals whatever h is. Okay, how about this one? The vertex would be at -3, the inverse of the inside and the obvious of the outside. So it's going to be at -3, comma, space, -4. The axis of symmetry is going to be at x equals h, which is -3. Again, the vertex, the axis of symmetry, that x value is always the x value of the vertex. Oh, look, a is negative, so this is going to open downwards. All right. Now, let's get to graphing. To graph this thing, the vertex would be at what? The inverse of the inside, so -6, comma, space. The obvious of the outside, -2. The axis of symmetry is at x equals -6, okay? Now, to graph a parabola in WebAssign, you've got to do it this way or you're going to get the wrong results. What you have to do, first of all, we're going to click on the parabola button until it turns blue. All right, we're not going to use the line button. We're not going to use the point button. We're going to use the parabola button. I am going to plot 2 points and in a specific order. First, I'm going to plot the vertex, and then I'm going to plot another point on the graph. If I do some other point first and then the vertex, my graph is not going to be correct. So the vertex is at -6, -2. Now be careful, notice the scale on this problem. Each square is 2 units. So -6, -2 is right there. Okay, now I need to find another point. Okay, so how am I going to do that? Well, let's see here. I am going to go back here. Hang on a minute. We have f of x equals the quantity x plus 6 squared minus 2. And we have the vertex at -6, -2. Okay, so going back to my whiteboard screen, let's put in a different x value than -6. Since our scale was each square was 2 units, let's put in 4. Okay, so let's find out what f of, excuse me, not 4, -4. F of -4 would be -4 plus 6, the quantity squared, minus 2, which is 2 squared minus 2, which is 4 minus 2, which is 2. So -4, 2 should be another point on the graph. Okay, let's see if it is. Oops, I got rid of my first point. Okay, so let's go back to -6, -2, and then -4, 2, right there. And let's see what it says. Okay, it's correct. Now, let me show you what happens if you don't do it in the right order. Okay, let's go back. And let's say, okay, I know that it contains the point -4, 2. So I'm going to plot that point first, -4, 2. And then I'm going to plot the vertex, -6, -2. And look, it opens downwards. Not only that, but it's wrong now. So WebAssign plots the points that you tell it to, but it depends on you putting in the vertex first. Okay, so let's go back here and do it right. So -6, -2. Oops, that point didn't quite get where I wanted it to. And then, what was it? -4, 2. I can fix that point though. Remember from when we graphed linear equations? My first point needed to be -6, -2. So I can go in and correct it. And now let's see what happens. Okay, let's do a couple more of these. So here, the vertex is going to be at HK. H is 5. But what's K? Well, there's no constant out here, is there? So K would be 0. The axis of symmetry is at x equals h, so x equals 5. Okay. I've got the point 5, 0. But now I've got to find another point. So let's see. We've got f of x equals negative the quantity x minus 5 squared. Oh, notice there's a negative sign in front. So this thing's going to open downward, isn't it? All right, since the vertex is at negative or at 5, 0, let's put in, how about 6? So let's find out what f of 6 equals. I'm going to go back to my whiteboard. And f of 6 is that, which is that, which is -1. So 6, -1 should be another point on the graph. Let's see if it is. 6, -1. And it says yes. Okay, I want to find one other one. Let's see here. Hang on, let me go to a different place. Things are moving slowly. Okay, open student view again. This time, let's take a look at here. The reason I'm doing all of this is I wanted to find one that had a fraction. Okay, let's take a look at this one. Okay, graph the pair of functions on the same coordinate systems. Okay, so we've got f of x equals 1/3 x squared and g of x equals -1/3 x squared. Okay, let's go back to the whiteboard screen. So f of x equals 1/3 x squared. The vertex is at 0, 0, isn't it? Okay, because think of this. Okay, so f of x equals 1/3 x squared would be like y equals 1/3 x minus 0 squared plus 0. In other words, when there's just the x squared term with a coefficient in front, the vertex is always going to be at 0, 0 because you don't have any other numbers affecting it. So let's go to the right. Let's let x equal 1. Okay. What would f of 1 equal? It would be 1/3 times 1 squared, which is 1/3 times 1, which is 1/3. And I did all of that because I wanted to get fractions. Okay, so I want to graph these 2 points. Let's go back to